solving a quadratic inequality. And so these are much like the other ones. There's multiple methods of solving them, multiple ways that we can do them. The first way I'm going to show you is using your graphing calculator. So you're going into Desmos. Log in. Pull up your graphing calculator. And now, just like yesterday, whenever we enter this in, we're not going to do the less than or equal to 0 part. We're just going to enter in the first half of the equation. So when we enter that in, x squared plus 3x minus 4. So now we're looking at this graph. Just looking at it, I can see where it crosses the x-axis, right? So I can see where my zeros are, here and here. Now it asks for when it's less than 0, less than or equal to 0. So at this point here, it's equal to 0. And from here all the way over to here, our red line is below the x-axis. So it's below 0 for all of that. Which means whenever we're finding the interval where it's less than or equal to 0, it's going to be from negative 2.351 to 0.851. Because that's an equal sign underneath there, it's going to be a bracket. And so if I don't specify how I want you to solve that, this is a great method to do it, because I can just plug my equation into the graphing calculator, find where it's equal to 0, and then this whole area is where it's less than 0. Everyone good with that part? Not too bad, right? Now there will be times where I might say, solve this algebraically. And that's where it's not nearly as fun. So if I'm asking you to solve that algebraically, what you're going to do for one like that is you're going to have to use the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember from Algebra 2, this is a, b, and c. So now we're just plugging these values in. Negative 3 plus or minus square root of 3 squared minus 4ac. I don't know why I put a and c in there still. A is 2, c is negative 4. all over 2a, which would be 2 times 2. When I start to solve this, b squared, it's 3 squared, which is 9. And then negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. Over 4. Nine plus 32 is 41. It's negative 3 plus or minus the square root of 41 over 4. If I plug this into the calculator, negative 3 plus square root of 41, close your parentheses, divided by 4, gives us 8.507, which is basically, 0.8507, which is basically 0.851. And then if I switch this to a minus, it gives us our other answer, negative 2.351. So those would be our zeros of the function. Or where y equals 0. Which we already found from the last half, right? But now we don't know where it's lower than that. Like, we can't tell just from those two numbers where my graph is going to be below 0 and where it's above 0. So if I'm asking you to solve it algebraically, you should also choose numbers on either side of this. So if I have, like on a number line, negative 2.351 and 0.851, I'm going to want to choose a number in between those two, which would be 0, because it's going to be the easiest one to plug in. I'm going to choose a number to the left, say negative 3. I'm going to choose a number to the right, say positive. We'll just make it 1, because it's going to be easier. In order to figure out where it's going to be less than 0, it could either be less than 0 on the outsides here or on the inside. Because we've seen the graph, we know it's inside, but I would usually start with the inside anyways. Does anybody know why? Because if I plug a number in on the inside and it's less than 0, then I don't have to try anymore. Whereas if I was doing on the outsides, I would have to try to plug both of these in and see if they both give me a number less than 0. Additionally, there's another way that you can tell if it's less than 0 or greater than 0. And it's to look back at the original equation. If a is positive, which it is in this case, it means that our quadratic is facing up. If our quadratic is facing up, then it's going to be on the inside, where it's less than 0. If this was a negative, it's going to be facing down, and less than 0 is going to be on the outside. It'll be all this area over here. The only problem is this isn't always going to be less than or equal to 0. Sometimes it'll be greater than or equal to 0 that I'm looking for. So if you're doing it algebraically, it's nice to plug one of the numbers in to just find out if it's going to work. So we plug it into our original equation. Our original equation was 2x squared minus 3x plus 3x minus 4. So if I plug a 0 into that, this would be 2 times 0 squared plus 3 times 0 minus 4. This is 0. This is 0. You're left with negative 4. Since negative 4 is less than or equal to 0, I know that it's this whole area inside of here is going to be below the x-axis. So that's how I would know that it's that interval. You guys are at a distinct advantage because you're at home. So a lot of this stuff could be done in a much easier way. Like I could say, do it algebraically, and you could just graph it, and there's nothing I can do to stop that because you're at home. But in general, once you get the gist of it, I'm not going to check your answers or anything like. I'm not going to make you check your answers by doing something like this. I would be fine if I say do it algebraically. If you would just do this portion of it to come up with these numbers, and then just give me this interval. I won't make you do the check because you have graphs at your disposal. All right. So really, that's it for the quadratic portion. There's another one where we don't have a quadratic. This is a much higher power. But since I know that this is a higher power, it doesn't really change anything. I know where my zeros are. If I'm looking at this, I can tell where every one of my zeros is. Do you know how? You just take each portion of this and set it equal to 0. X plus 5 equals 0, x minus 2 equals 0, and x minus 8 equals 0. It gives me x equals negative 5, x equals 2, and x equals 8. Now if I'm looking at a number line, it tells me my graph is going to cross at 3 places. In negative 5, 2, and 8. So if I want to know where it's less than or equal to 0, I need to pick numbers within each one of these intervals. I can do negative 6. The easiest number between negative 5 and 2 is 0. And I can do 3. And a number bigger than 8 is 9. So I need to test each one of these points to find out when I plug it in, is it less than or equal to 0. If I test negative 6 out, negative 6 plus 5 is negative 1. Negative 6 minus 2 is negative 8 to the 6th power. And then negative 6 minus 8 gives me negative 14. If I was to multiply this number out, I would get a tremendously big number. Do I even have to multiply it out there? Can I tell whether it's bigger than smaller than, whether it's bigger or smaller than 0 without multiplying? If I look at this portion, absolutely. If I look at this portion, any number raised to the 6th power is going to become positive. So that's going to be positive. On the outside, I have a negative times a negative, which creates a positive. It tells me that this whole number is going to be a positive number. So it can't be less than or equal to 0. So I know that this area is not less than or equal to 0. So these would all be positive numbers back here. If I look at the area between negative 5 and 2, I'm going to do the same thing. 0 plus 5, 0 minus 2 to the 6th power, 0 minus 8. Positive 5, negative 2 to the 6th power, that would become positive, and this one is negative. Positive times negative gives me a negative number. So everything between here and here is going to be negative. Let's plug 3 in. Three plus 5 is 8, times 1 to the 6th, times negative 5. One to the 6th is positive, 8 is positive. I have a positive times a positive, so that's positive, times a negative. It makes this negative. Then plug 9 in. 9 plus 5 times 9 minus 2 to the 6th times 9 minus 8. Gives me 14. This is 7 to the 6th power, and this is positive 1. Positive times a positive times a positive means that this is going to be positive. So now when I look at this, I'm looking for where it's below the x-axis, which means where it's negative. This is negative. From negative 5. At 2, it's 0, because that's a 0 that we found. And then it comes back down and then into the negatives again. So this wants to know when it's less than or equal to 0. It's from this whole interval here, from negative 5 to positive 8. Does that make sense? So when I give my interval, it's from negative 5 to 8. And that's my answer. Yep, because you have it. Exactly, because I have an equal sign underneath the S there.